Hi guys, it's Miss A here, and in this video we are going to be talking more about trigonometric ratios and more specifically how we use SOHCAHTOA to find the length of missing sides. So as a refresher of what we have reviewed already is that SOHCAHTOA is an abbreviation that helps us remember the ratios of the sides of a triangle. So the SO in SOHCAHTOA means the sine of an angle is the side opposite over the hypotenuse, where the cosine of an angle is the adjacent over the hypotenuse, and the tangent of an angle is the opposite over the adjacent. Okay, so let's use SOHCAHTOA in an example here. So here is a right triangle, and that's important because remember that SOHCAHTOA only works with right triangles. And in this example, they are giving us the length of 3 sides, but no angle measurements. That's okay. They tell us that this angle is theta, an unknown theta. And just on a side note there, whenever you see that symbol, that means theta. And it's kind of used as like x. So they're asking us to find the ratio here. So no problem. So first what I did is I set up our ratios here. There's our SOHCAHTOA. So I'm just going to fill in what I know. So across from the 90-degree angle, remember, is always and forever going to be your hypotenuse, the longest side at 13. So anywhere where I see what I abbreviated as HYP, I'm going to put a 13 in there. Next, we are going to find the opposite side to theta. Remember, here's theta here. So let's look to find what is the side opposite theta, and that is going to be our 5. So anywhere where I see opposite, sorry, my 5's not cooperating there. Anywhere where I see opposite, I'm going to write in a 5. Next, we want to find the adjacent. And adjacent means the one right next door to theta. So it looks like that theta has 2 next door neighbors, but it can't be the hypotenuse because we already labeled the hypotenuse. So instead, theta's next door neighbor is this 12 here, and so this side is the adjacent. So anywhere where I see adjacent, I'm going to put in a 12. And those are our ratios. So how you would say this is the sine of theta equals 5 over 13. The cosine of theta is 12 over 13, and the tangent of theta is 5 over 12. Now, sometimes it's a little easier to think about these fractional forms in decimal forms. So if you just simply type in 5 over 13 into your calculator, you would get 0.3846. Oops, 3846. 12 over 13 in your calculator would give you 0.9231, and then 5 over 12 would give you 0.4167. So remember that these are rounded. I just chose to round them to 4 decimal places. So let's take this SOHCAHTOA to the next level here. So thus far, all of the examples that we've done have only given us the length of 3 sides. And we've been calling these angles like x, or maybe we call them theta or whatever. We haven't really been saying what the angle measurements are. But now we do want to start talking about these angle measurements. So I also want you guys to notice that this right here is our special triangle of 45, 45, 90. And I chose this one because we know the sides and the angle measurements already. So I want to show us how we can start using the sine of 45, the cosine of 45, the tangent of 45 with actual angle measurements. So I set these up the way that we always do. We look at our SOHCAHTOA. I'm just going to set those up in advance, so all that I need to do is just fill in the blanks of what we have here. So let's look at what is our hypotenuse. Well, our hypotenuse is always the side opposite the right angle. So our hypotenuse is 1 root 2, which is also just root 2. So anywhere where I see hypotenuse, I'm going to type in root 2. Next, I'm going to look at the opposite of 45. Well, the opposite of 45 is going to be 1. Fill that in, and you notice that even if I look at the opposite over here, well, that's also 1. All right, let's look at the adjacent. Adjacent is the side next door. So its next door neighbors are those two, but we know it's not the hypotenuse because we already labeled that. So instead we see here that our adjacent, well, is also going to be 1. Just like the same here, if I looked at this adjacent would also be 1, so I'm just going to fill that in. So what I would like you to do next is grab your calculator, and I want you to type in what is 1 divided by the square root of 2. Well, that is going to give us 0.7071. 1 over root 2, same thing, same math. And remember that I'm just typing this into my calculator. And of course, 1 over 1 is just 1. So what I'm going to do on the next page is show you how you use a scientific calculator to actually find what is the sine of 45, and the cosine of 45, and the tangent of 45. So continuing on with the example that we were talking about on the previous page, I want to show you guys how, in that previous example, you already found the ratios of these different sides. So remember that as we go forward in these trigonometric ratios, we're going to need a scientific calculator. So if you have a handheld one, awesome. If you want to use your phone, that's fine. I like Desmos.com. It's a free online scientific calculator. Remember that when you use calculators, whether it's on your phone or handheld or on Desmos, it must be in degrees. The other option that you sometimes see is rad, which is short for radian, but you do not want radian. We want to see everything in degrees. So just remember that, that the setting must be in degrees. So then all that you do to find the sine of 45 will just touch that button, the sine of 45, press enter, and check it out. That is the same ratio that we found right there. To find the cosine of 45, you do the same thing. Type cos, and then 4 and 5, and enter. Same ratio. And then you do the same thing with tangent. You press tan, 4, 5, enter, and you get the 1. So let's review the sort of problems that we looked at so far. So far, we've looked at triangles where we have been given all 3 side lengths and asked to find the ratio. And then we were given all 3 sides and an angle, an actual angle measurement. Instead of x or theta, they actually started giving us an angle measurement, but we still had 3 sides. So now we're taking it to the next level where they give us one known angle, 50 in this example, and only one known side, 23 in this example. And we are being asked to use SOHCAHTOA to find the missing length of x. Well, how do we do that? We use our SOHCAHTOA ratios in the same way, and then we use a little bit of algebra. So here I am setting up our SOHCAHTOA, just like we always do, and I'm just going to start filling in the blanks. So here's my hypotenuse, the longest side across from the right angle. Well, they don't tell us what the hypotenuse is. They just call it x. So that's not a problem. Anywhere where I see hypotenuse, put in an x. Now they're asking about the sine of 50, the sine, cosine, and tangent of 50. So I'm going to look at that 50, and what is the side opposite 50? It's that y. We don't know what y is, but that's okay. We just put that right in there. Adjacent to 50, 50's next door neighbor, is going to be that 23 right there. So 23 is the adjacent. Remember that 50 also has the next door neighbor of that, but it's not the hypotenuse, because we already labeled that as the hypotenuse. So the next door neighbor is 23, so I'm just going to write in 23 right there. Okay. So now that we have our ratios, let's go back to see what this problem is asking us. This problem is asking us to find the missing length of x. Okay, well, let's look at our ratios, and we have to decide which one is going to help us. So as a reminder, all of these ratios are totally correct. They're all correct, but only one of them is actually going to be useful for us in finding x. Well, it's probably not going to be this first one, because we have 2 unknown variables. We don't know what y is, so the sine of 50 is not going to be of much use. It's correct, it's just not useful. The same thing down here with the tangent of 50. Well, we only have one unknown variable here of the y, but that's not what they're asking us to find. They're asking us to find the length of x. So that's not going to be very useful either. So it looks like that the winner here that's going to help us find that missing side is indeed the cosine of 50 will equal 23 over x. And on the next slide, I'm going to show us how to find that. So to continue on with this example, so we found on the previous page that the cosine of 50 degrees equals 23 over that unknown x. So our goal here is to use algebra to isolate that x to get an x whatever. That's my goal. What does x equal? Because they're asking us to find the missing length of x. So let's talk about this algebra a little bit. There are a couple ways that you can think about it. So remember that my goal is to isolate x. So I could do this a couple of different ways. So you could think about it as multiplying this side by x. You could even think of it, if you wanted, as x over 1. Well, whatever I do to one side, I got to do to the other. So that goes away, because remember that x over x equals 1. Any number over itself equals 1. So I'm just left with 23 right there. Then on this side, I'm left with x times the cosine of 50. Now let me talk about what the cosine of 50 even means. The cosine of 50 is its own number. Its own number by itself. So this doesn't mean like the cosine times 50. It doesn't mean that. It doesn't mean, that x, times cosine times 50. It doesn't mean that. It does not mean that you could do like, x times cosine, and maybe you want to divide both sides by 50 by itself. That is not correct either. Rather, cosine, just think of cosine of 50 as its own individual number. So you want to treat it as cos 50 kind of come together as just one value. So here we are. Remember that we want to use opposite operations. Remember opposite operations when we're solving for equations here. So because cosine of 50 is being multiplied, I'm going to divide both sides by the cosine of 50. That goes away, leaving me with x equals 23 over the cosine of 50. And how do you do that in a calculator? Well, I did it for us right here. So type in 23 divided by, and then type in your cos 50, and then press enter. And you get this number right over here. And you can go ahead and round that to, let's say, 35, how about 0.782? 35.782. And that is your answer. And what that answer means is that the length of this x, in this example, it's the hypotenuse, the length equals 35.782 inches. And that is your answer. Oops, 35.782. Okay, let's look at another example where, again, they are giving us one known angle. Well, in this example, it's 25. One known side, they're giving us 10. And they are asking us to use SOHCAHTOA to find x. All right, not a problem. Let's just set up our ratios and let's fill in the information that we do know. So what is the side opposite the 90 degrees? Is the hypotenuse. Well, this time they actually gave us what the hypotenuse is. So anywhere where it says hypotenuse, I'm going to put in a 10. They're asking for 25, so I'm going to look at the side opposite 25. Well, that's y, so not a problem. Anywhere where it says opposite, I'm going to put a y. Okay? Right next door to 25 is the adjacent of x. So anywhere where it says adjacent, I'm going to put an x. So let's review which of these ratios is going to help us. Because remember that all of these ratios are correct, but it depends on what we're being asked to find. And they are asking us to find x. So this tangent isn't going to help us, because we have two missing variables there. So although it's correct, it's not going to help. Same thing here. Well, this would be helpful. We could use this ratio if we were being asked to find y, but we're not. We're being asked to find x. So indeed, the cosine of 25, which equals x over 10, is our winner to find what this missing length of x is. So let's check that out on the next page. So continuing on with this question, we are being asked to find missing length x. So we found that the cosine of 25 degrees equals x over 10 is the ratio that we want to use because we want to isolate that x. Our goal is to isolate the x to get an x equals whatever that's going to be, because that is what we're being asked to find. So we need to use algebra. So in the previous example, I just multiplied both sides by this denominator, and that would have given us 10 cosine 25, because remember, I need you to think of cosine 25 as its own value, its own number, equals x. So that's totally fine. Like, you can do it that way, but I just want to show you another way to think about it if this is a little easier, and that would be cross multiplication. So you can also think of this cosine 25 being over 1. So we could have the cosine of 25 over 1 equals x over 10. And if that's a little easier for you to think about it that way, that's totally fine. Because then what you can do is think about your cross multiplication as 10 times your cosine of 25 equals x times 1. And x times 1 is, of course, just x. So there is your answer right there. And how do we plug this into a calculator? Well, remember that this is like 10 times the cosine of 25. And the cosine of 25 is its own value. So what I did is I plugged in here just a 10, 1, 0, times, I'm then going to plug in COS 25, enter, and that is going to give us that answer right there, which is, what is that? 9.0631. That's rounded. So this x right here, I'm going to say 9.063. I'll just round it to 3 decimal places down there. So that is the length. This is actually 9.063 millimeters, because that's what the question is in here. So that's the length right there. Why isn't this cooperating? Okay, so that is the length of this side. Now, few things on this. One, I have a lot of students ask me, because remember on the previous page, we had, it was the cosine of 50, and it was, I think it was 23 over x. And we ended up with the cosine of 50 equaled 23 over cosine 50. So I have a lot of students ask me, well, how do you know whether you divide the cosine or whether you multiply the cosine? Well, it really depends on what's in your denominator right here. So that's why I typically recommend the cross multiplication way, because then that helps you see when you should be multiplying and when you should be dividing, because again, it really depends whether your variable is in the numerator or if it's in the denominator. And then I also have students ask me, well, how do I know how many decimal places to round it to? Usually 3 or 4. Usually 3 or 4. You can tell in the question. Occasionally it'll be 2, but usually like 3 or 4 decimal places. All right, guys, here's another example here. As always, there are my SOHCAHTOA ratios all set up there. They only gave us one known angle at 40 and one known side at 9, and they are asking us to find x. All right, not a problem. What do we always know? The side opposite the right angle is the hypotenuse. Well, they don't tell us what it is, but they tell us it's x, so that's not a problem. They are asking us about 40 degrees, so I'm going to look what is opposite the 40 degrees. Well, that's the 9. So no problem. 9 and 9. What is adjacent to the 40 degrees? Well, that's going to be the y. We don't know what y is, but we can still just use it as the adjacent there. So there we go. So, as always, the question is, which of these ratios is actually going to help us find x? Well, it's probably not going to be the tangent. The tangent we could use if we were trying to find y, but that's not what it's asking for. The cosine isn't helpful because we have 2 missing sides, so let's just get rid of that. So our winner is the sine of 40 equals 9 over x. Let's check that out on the next page. All right, so here we are now continuing on with this question, and we determined on the previous page that the ratio that we're going to use is the sine of 40 degrees equals 9 over x. and they are asking us to find missing length x, so that's what I want to solve for and isolate. So I'm going to use some cross multiplication here. And let's see what this gives us. So the sine of 40 times x. So x times the sine of 40 equals, do a little cross multiplication, 9 times 1 is of course 9. So using what we understand about algebra, remember I want to use my opposite operations, and because I want to isolate this x, I'm going to use opposite operations. Because the sine of 40 is being multiplied, I'm going to divide both sides by the sine of 40, which means that that goes away, leaving us with x equals 9 divided by the sine of 40. And that is your answer. Let's plug it into our calculator. Well, first, just 9 divided, and then I'm going to type in the sine of 40, enter, and that's going to give us that answer right there. So x equals 14, what is that? 0015. 0015. And that is your answer. So the length of this hypotenuse right here, this length is going to equal 14,0015 meters. And that is your answer. And I want to do one final question for you guys, and this is a challenge question. You would not see something this complicated on an exam or on homework, so don't worry about that. But I do want to show you how we can use all of these different ratios to find how we could find both x and y and basically complete this entire triangle using all the different ratios available to us. So here's what I mean by that. So we have just our standard right triangle here, and they give us just one angle at 55 degrees. Okay, well, we also can find what this missing angle is because we know that the interior angles of all triangles will equal 180. So I'm going to take 180 minus 90 minus 55, and that is going to give us that missing angle right here of 35 degrees. Oops, sorry, I don't know why that won't right. There we go, 35 degrees. So over here on the right, I'm going to fill in all of these angle measurements that we're looking at. So sine, cosine, and tangent of 55, and also sine, cosine, and tangent of that 35 that we just found. Next, what I'm going to do is continue to fill in the ratios. So let's first work with the angle 55 here. So the hypotenuse is still the hypotenuse across from the 90 degrees. Well, that's y. So anywhere where I see that, I'm going to plug in y. Across, opposite of that 55 is going to be its opposite side of x. So let me fill in x. And finally, for the last one, the side adjacent to 55 is going to be that 18. All right. So let's do the same thing for that angle of 35. Now I'm going to erase what I wrote because the opposite and adjacent of 35 is going to be different. The hypotenuse is still y though. That hypotenuse is not going to change. So we still have y right there. Let's look. The opposite of 35 is going to be that 18. And the adjacent of 35 is going to be that x. So type in x, and there we go. So now I'm going to show you on the next page how we can use now these 6 different ratios to help us fully complete this triangle to find x and y. So continuing on with this challenge question, I rewrote all of the same ratios that we had on the other page, just kind of cleaned it up. And I want you to notice a couple things. I would like for you to notice that the cosine of 55 and the sine of 35 are the same thing. Both of them equal 18 over y. And I just want for you to notice real quick that 55 plus 35 equals 90 degrees. I also would like for you to notice that the same thing happens over here. That the sine of 55 and the cosine of 35 both equal x over y. And again, I want you to notice that 55 plus 35 equals 90. So I just want you to notice those patterns, and you'll see why, because all of these are going to fall together right now. All right, so how can we solve these? So right now, based on the information that we have, well, that's not going to be of much use, not right now, because we have 2 missing variables. Well, the same thing here, 2 missing variables. So really, we could solve for y there, we could solve for y here, we could solve for x down here or x down there. Either way, let's just focus on those that have just 1 missing variable. So here we go. I'll do this one first. You can really do it in any order. So I'm going to look at my cross multiplication here. And so this is going to give me y times the sine of 35 equals 18. I am trying to isolate the y, get the y all by itself, so I'm going to divide both sides by the sine of 35. Sorry, that's a little crushed in there. That goes away, leaving me with y equals 18 over the sine of 35. So I type into my scientific calculator simply 18 divided by the sine of 35, and that is going to give me a y equals 31. I'm just going to round it to 2 decimal places. 31 point, actually I'm going to round it to 3. 382. 31.382. So that's my y right there. So y equals, that length is 31.382 0.382. This problem is in centimeters, so there is one missing length. Now, remember that the sine of 35 is the same as the cosine of 35. So even though I don't necessarily have to, I want to show you anyhow how we can use either one to find y. So here is the same thing. I'm going to use my cross multiplication to see that y times the cosine of 55 equals 18 times 1, which is 18. I am going to divide both sides by the cosine of 55. Cosine of 55, that goes away. Remember, we're wanting to isolate the y. So y equals 18 divided by the cosine of 55. And if you type that into your calculator, you are going to get the same answer of 31.382. And that's exactly what we expected. Cool. So now let's use the tangents down below to find what that x is going to be. So let me just make a little bit of room here. Okay, so the tangent, let's do this one over here. The tangent of 55 equals x over 18. So let's do a little cross multiplication. That is going to look like 18 times the tangent of 55 equals cross multiplication. X times 1 is just x. Okay, so in this situation, we're not dividing. X is in the numerator, so you simply type into your calculator 18 times the tangent of 55, and that is going to give us an answer of 25.707. Why won't, there we go, 707. So there we go. We just found x. So x, so that's right down there. Oopsies. So x is, sorry, I don't know why my ink keeps, there we go. So x is going to equal 25.707 centimeters. And there's x. So as you've probably already noticed with this pattern, is that if I do the same thing over here with the tangent of 35, well, it's going to give us the same answer. So if I do some cross multiplication to give me that x times the tangent of 35 equals cross multiplication, 18 times 1 is 18. I'm going to divide by both sides by the tangent of 35. That goes away, leaving us with x equals 18 over the tangent of 35. And if you type that into your calculator, 18 divided by the tangent of 35, check that out, we got the same answer, 25.707, which is exactly what we expected. So on the next page, I am going to look at these ones that we had crossed out before. Okay, so again, continuing on with this question, I have cleaned this up a little bit because I want to show you how you also could have used these ratios to find the ones that we didn't use. So before we didn't use, I'm looking up here at the sine of 55. So let's just pretend that we don't already know what x and y is. We already know what it is, but let's just pretend for a moment that we don't. So first, we had found y to be 31.382. So let's see how we could have used that to have solved this. So we could have said earlier that the sine of 55 over 1 equals x, and remember we're pretending that we don't know what x is yet, and let's just plug in that y of 31, oops, sorry, I don't know what, there we go, 31.382. 31.382. Sorry, there we go. So I just used some cross multiplication here, and that would give me 31. There we go. Jeez, okay, 31.382 times the sine of 55 is going to equal x. Now, if I'm doing all my math correctly, if I type into my calculator the sine or 31.382 times the sine of 55 and check that out, I get that x equals 25.707, which is exactly what we expected. Let's look at the cosine of 35 over here. Again, let's pretend for a moment that we don't know, let's pretend that we don't know what x is again. Or you know what, let's do y. So we can say, oh yeah. So let's say the cosine of 35, and we're saying that we're pretending that we only know what y is. So x over 31.382. And you guys probably see where this is going, where if I just do some cross multiplication here, so 31.382 times the cosine of 35, oops, the cosine of 35 is going to equal x. And as you probably guessed, if we just plug 31.382 times the cosine of 35, well, that is going to give us x equals 25,707. So in other words, I just wanted to show you this page because there were other ways that we could have found x and y after we found either x or y. So there were all these different ways that we could have solved for this. So that's just what I was trying to show you on this page. So one more page because I want to show you how this all comes together with the Pythagorean theorem. Okay, so we found the lengths of the missing sides, and I just want to show you one last thing. Well, I guess two last things. So first, I want you to notice that, so we have three angles, right? 90 is the biggest angle, and it's across from the longest side. which is what we expect, and that's always a good check. So 31.382 is the longest. Well, 35 is the smallest angle, and guess what? It is across from the shortest side. So 35 degrees is the smallest, and it's across from the shortest side. And as you can guess, that 55 is in the middle, and that 25,707 is the medium length as well. So I just want you guys to notice that first. And then the second thing that I want to do here, and then this will be done, is I want to show you that the Pythagorean theorem works. So we found all these different lengths, right? I'm going to call that A and that B. You could have done a reverse, but we're just going to do it like that. And remember that when using the Pythagorean theorem, your C is always going to be your hypotenuse. So let's check this out. So we have A squared plus B squared equals C squared. That's our Pythagorean theorem. I'm going to plug in these numbers. So first I have 25,707 squared plus that B at 18 squared equals our hypotenuse at 31.382 squared. So 25,707 squared. So I'm not going to type all of what the answers are. Just put it into your calculator. And on that side, when I just put into my calculator, that's going to equal 984. Oops. So this side is 984.85. Okay. Jeez. My pen's getting away from me here. Sorry. Okay. And then on the other side, 31.382 squared. Well, that is going to give us 984.83. So it's not exact, right? It's off by just a little bit, but that's because we were rounding here and here. So if you had plugged that in exactly, it would have been exact, but it's just a little bit off because of rounding. But we can still see that the Pythagorean theorem works on this final triangle.